Hey everyone, I'm Michael, and welcome to another Thundershock Dev update. So the progress we made today. First of all, I gotta get a few things off my chest right now. First of all, I apologize for not streaming this past weekend. I wanted to do a stream on Sunday, but then, well, Canadian heat waves are fun. I really don't want to run a PlayStation 3 and my gaming computer in the middle of a heat wave because running the gaming computer on its own is enough to freaking make this room a goddamn oven. But I, it's not the only reason I couldn't stream. I'm gonna solve the heating issue in here by simply buying an air conditioner in a few days when I can afford it. And then I'll solve that issue right then and there. It'll actually be comfortable in here and I'll be able to do that. Another thing that we've been doing this past week is we're switching internet service providers because we can get a better upload speed, and that's of course amazing for doing live streams. And that's a little bit in progress right now. It's gonna happen tomorrow, um, hopefully, and then I'll be able to have much better stream quality because our upload speed will be about 3 times what it is right now, and it's very, very low right now. So, yeah, that's in the works. So I couldn't stream because we're dealing with some stuff in the back end here. But I'll be back to it hopefully this weekend. If not, then next weekend I will be back to regular streaming. And it'll most likely be Little Big Planet. Anyway, back to Thundershock. I had to do a complete rewrite of the audio system, so I want to show you guys what I've done. First of all, I want to show you it working. Now, as far as... there are two components to the audio system. There's the sound player system, and then there's the music player system. And the reason we have both is because music is a lot more complicated to set up than sound effects. With sound effects, they're generally you load it in and you fire and you forget. Um, with music, you have to... generally, they're going to be very large files, and large files are not good to load into RAM. So music is buffered, so only a small portion of the file is loaded in at once. Um, and that was very difficult to get working. Now, I had music working last week, and I had sound working last week, but I noticed a lot of architectural issues and general bugs with the whole system that were insanely difficult to fix. I'm not going to go over what those bugs were because, quite frankly, it's hard for me to explain even in code what the hell is going wrong, let alone in English. But rest assured, it forced me to rewrite the entire system and rethink how it works. And I'm going to show you guys that it is, in fact, now working. Now, as far as music goes, you're going to hear some interesting music that I pulled off of CC Mixter, which is licensable for games. And in the future, ideally, I would like to get either custom soundtrack made or I'd be able to license music to be made for the game or to be used in the game. But for now, I'm using some royalty-free music. It'll work for what we're doing. So yeah, you're gonna hear some of what I'm planning to have the music sound like. This is not final music for the game. This is not official soundtrack. This is temporary. So, yeah, let's get into this. But I do have sound effects that are official and final, so... Anyway, let's get into this. So, as you can see, I have a very broken version of the new Red Team intro in. It's not broken, it's working perfectly fine, it's just very much unfinished. Now, there was a lot going on there, and I closed out of it. I really shouldn't have, but I needed I needed to be able to talk, and that was very loud. But either way, there was a lot going on there. There were two audio-related things going on. There was music playing, and there was a glitch sound playing. Now, that glitch sound loaded in perfectly. I specifically licensed that sound effect for the game, so that's great. But there was also music playing, which is not something we could do earlier. as of a few hours ago. So, how does this all work? Well, I'm not going to go into the super technical details of it, but the bottom line here is that I use OpenAL for my audio. Now, OpenAL lets you do all sorts of cool things with, like, 3D audio and all that stuff, but I'm not using that in this engine. I might not even expose that feature unless we start making 3D games. But basically, Thundershock is built on 3 levels here, as a game engine. We have the core of the engine, which is sort of all the abstraction and core components of the engine. Like, our font system is in here, because that's a pretty low-level thing. Same with game time and all that stuff. That's our core level, or core layer. Then we have the platform layer, which implements all the abstractions of the core layer. So this is where our graphics rendering is done, and our windowing, and all that stuff. And you can see there are bindings for SDL2 in here. That's how we do our windowing. So that's what Thundershock.OpenAL is. And then we have the game layer, which is, well, the rest of the engine. This is where things like scenes and game components are, and all that stuff. I lost my words for a sec, but this is what you would have referenced if you were using Thundershock in mono game. In fact, there's probably still some mono game code in here. I've tried to get rid of most of it, but there's still the Thundershock content folder. That's still there, even though it's mostly empty now. But yeah, and audio spans all 3 of these projects. First of all, we have Thundershock.core.audio, which is the low-level abstract audio layer. And that's the Thundershock project I just clicked on. Thundershock Core Audio. This is where we have our backends, our outputs, and our buffers. And in fact, that's directly in line with how OpenAL works. In OpenAL, we have listeners, sources, and buffers. They directly map. The backend is the listener, because you can only have one. The output is the source. So a source is, think of like your car's engine, or the PC speaker that beeps at you when you turn on your computer. Audio comes from that. And then buffer is where that audio is stored. And the analogy that people use in OpenAL is that the listener is your ears, or the player. The buffer is a CD, and the source is the CD player. And in Thundershock, it's generally the same thing. So that's our core implementation, and of course, or our core abstraction of the audio system. Of course, we have an OpenAL implementation of this whole system, which is, well, just OpenAL. It's all in here, and I'm not going to go through the code. It's insane. There's an insane amount of code making this work. And then we go into the game framework, which further abstracts it away into music player, song, and sound. Now, what are the difference between the two? Or what is the difference between the two? Well, sound, the way it works is kind of pretends to be a single buffer of music. Now, it's not actually a single buffer. It does, in fact, buffer in the audio, just like the just like the song system does, which I'll get into in a minute. But for all intents and purposes, a sound is a single audio buffer. The reason it's not actually a single audio buffer is for something that I will get into very soon, which involves the glitch effect sound, by the way. So sounds are sort of your fire and forget. You load in the audio file, the engine buffers everything in, all at once. And generally, this is why you should use small audio files for this, because it's going to take up RAM, and it's not going to stream in from the file. It's going to load the entire thing all at once as a sound effect. And then you want to play it, you call play, and it plays. It's as simple as that. Now, stop, I don't know why that exists, because it'll automatically stop when it's done playing. I should probably make this this private, because nothing uses the stop feature. In fact, you don't really need to stop a sound effect while it's playing. Yeah, just play it, and it plays. It's as simple as that. So, yeah. You have your usual things here, like volume. And as I'm about to enter, or wait, no, power is right there. I just put it in with the private variables. This is why you have coding practices, Michael. Anyway, we'll move that down here. Properties generally be in a properties section, with private variables being in a private variables section. They should never intermingle. Anyway. So why is this whole thing buffered? Well, I'll get into that. But first, let's go into the song and see how that works. Now, a song is a little different. You load the audio file in, but it doesn't immediately get loaded in. It just, all the header information gets loaded in. So things like the sample rate and the channel count, that gets loaded in immediately. But everything else gets streamed in later on by the music player, which has a whole bunch of console commands and stuff that you can use as well. And it's a static class. There's only one music player, and in fact, only one song can play at once. Two can technically play at once, but that's for crossfading. And this is a whole bunch of convoluted code that I should probably comment, but basically the entire thing of it here is this is multi-threaded, and that's so that it doesn't take up frame time trying to stream everything in. And this is very complicated. The meat and potatoes are basically here in this playing buffer processed method event handler, and the other meat and potatoes is here in this read initial. And then there's things like play song and stuff like that for setting up crossfading. But I'm not going to get into all that stuff because it's very easy to demo with a console command. But basically, this read initial here is for when the song initially starts playing. It's going to read in 4 frames of the song. And by frames, well, that's just a partial... This is a section of the song. It's like less than half a second long. So it's going to read in 4 of these, and it's going to create 4 low-level buffers for these frames. And it's going to give the low-level buffer the frame as the buffer data. And of course, it's going to match up the sample rate and channels and stuff like that and get it all working. And then it's going to queue up the buffer to the audio output. That's the crux of how this all works. So we load in 4 audio buffers. Actually, it might be 3. Or 4 or 5. I don't know. This makes me think it's 5, but it could be 4. It could be any number. Actually, it's going to be either 4 or 5. Either way, the number doesn't matter. The point is, however many gets loaded here, that's the amount of buffers that will always be used. There will never be more created for the song. Also, this is named bug. I messed that up. That's a typo I'm not fixing. Anyway, once those initial buffers are loaded, the audio will start to play. And then what's going to happen is whenever a frame of audio has played, we're going to get this buffer processed event. And it's going to give us the instance of the audio buffer that was processed, which means the audio that just played. And then what we're going to do is we're basically going to check, did this event actually come from an audio output? And if so, which one? And based on that, we're going to read another frame from the song. Then what happens is we check the frame that we just read. If it has anything in it, then we're going to reuse this buffer and submit the new frame data to it, and then we're going to queue this this reused buffer to the song. So effectively, what should happen is throughout the entire song, the same 5 buffers should keep playing in a loop. It's just that each time the buffer plays, it has more audio, or it has different audio data in it. And then, what happens if we get no data when we read the song? Well, we delete the buffer. That's going to have the effect of, once the song finishes, all 5 of those buffers are going to be gone. They're going to be deleted. So that's basically how this all works. And I'll tell you right now, it was freaking hard to set up. But the result is that we can now play music and sound effects independently of each other and at the same time. Like this. And unlike with monogame, there's no dip in the frame rate, there's no hackiness going on as far as the visualization goes, and there's no choppiness with the audio. And, unlike in monogame, there are console commands, so I can play a different royalty-free song that I have for the game. And as you can hear, it just works. And with that said, I've been Michael. Hope you enjoyed the video, hope you learned something, and I will see you guys in the next one. Thanks for watching.